Right, this is Mr. Palmer. Got another video for you here on computer science. So before you watch this one, make sure you go over your notes on low-level languages. So here we're looking at translators. This one is going to focus on assemblers. So big questions for this video are: why do you need a translator, and how does an assembler actually work? All right. So a quick refresh for those of you who didn't take the time to go over your notes. If you remember, back in the day, programmers used to work in binary. We then moved on to using assembly language because it is easier to work with, and then now we work with high-level languages. So we've got that increased abstraction, moving further and further away from the actual machine code. All right. So assembly language basically took an opcode, for example, the 100101, and then it replaced it with a mnemonic. So it became easier to work. You weren't working with the opcodes and binary addresses. You were just working with like some form of simplified instruction and an abstract variable name. Okay, but a dilemma there is that the machine basically speaks machine code, right? Binary, whereas we are working in some now form of human language. So or something closer to human language. So that's Jacob something, I forget his name. He's one of the co-founders of Vimeo. All right. And there he is talking and writing his assembler. Okay, on the other side you can see that we've got the machine working in machine code. So we need something that can basically translate from his assembler to his assembly language, the program is written in assembly, to machine code. Okay, and that's basically what an assembler does. Okay, an assembler is one form of translator, and it translates assembly language into machine code. So something that we can understand into something a computer can understand. Alright, so basically, whoa, this is a weird animation. Alright, you got your source code that gets fed into a translator, which then creates machine code. Alright, this diagram is the basic version of the diagram, and as we move on and we learn about the different forms of translator, you will see the machine, it will get more and more complex, and you might even want to label it up further with more bits and pieces to explain what's going on. Alright, so the first type of translator then here is an assembler. Okay, and the tasks performed by an assembler basically are that they convert mnemonics into opcodes. So you'll add, store, load, whatever it is, into a binary opcode. It takes a symbolic address, e.g. num1, num2, x, y, that identifiers you've given to your data, your variables. Okay, it takes those symbolic addresses and it converts them into memory locations. Alright, and finally it takes your constants and it converts your constants into a binary form. So any decimal number, integer, any hex code that you might have, any textual data, where for example in ASCII would be converted to its numeric format in binary. Okay, once all of that's put together, you've then got the machine code that can be executed on a particular CPU. Alright, remember that different CPU architectures have different instruction sets, and so therefore they would have their own translator that will create machine code that they can run. Alright, just to go back over to add something else to this as well, you can also have a process of cross compilation, right, where you have a translator, okay, an assembler on an Intel x86 platform, and that will create some code, machine code that will run on like a Motorola whatever processor. Okay, there are software tools that can do that. Alright, and those of you who twigged it, obviously translators are software. Okay, so the big questions are: why do you need a translator? So you should be able to think back and think about the fact that machine speak machine code. We are writing in some form of higher level language. Well, not high level. Assembly is a low level language, but we are writing in something that's easy for us to understand. So we need to translate that easy human readable program into something that a computer can execute. And how does an assembler work? It's there in your notes. It should be. Alright, it's translating the opcodes, it's translating the symbolic addresses, and it's doing the conversions on the constants. Okay, watch out for the next video, and that one's going to be continuing on the theme of translators, looking at interpreters and compilers.